Okay. Okay, let's just start. You can jump in later. Okay, today's class, since it's the first class, so it's gonna be pretty short and brief, mostly just introduction. So hello everybody again. Good morning. My name is Yuchan Yuan. You can also just call me Lotus. I'm teaching you network analysis this semester, and it's my first time teaching. So I guess we all learning something here, hopefully. My office is on ninth floor Rhodes Hall. I have an open door policy, which means you can always just stop by and talk to me if you need any help, or you have any questions. You can, I think if some of guys don't know where is the ninth floor Rhodes, you can go up there through the stairs next to the electrical engineering department office, or there's elevator as a connection between the Rhodes Hall and ERC, or now it's called Mentai Center. There's elevator and you can take there to ninth floor. Majority like stuff in ninth floor is just some lab offices. So my office is 933 and you can find there. I work with Dr. Jason Heikenfeld in the Novel Devices Lab on electrical chemical biosensor. So if any of you interested in doing research in this area or just generally doing research, you have any interest in doing that, and you are really also welcome to talk to me and have a little chat, maybe have a lab tour or something like that. So the TA of this class is Maha. She will grade your homework and host office hours every week, and your lab and test will be grading by me. Because this ongoing COVID situation, and she has a newborn baby at home. So the office hours she hosts every week, starting from the third week, will be all online. And there will be more information about this office hour later this week. I will post it on the Canvas so you guys can see. Any questions on this? Oh, also, so since I'm sharing the PowerPoint here, so I didn't really can see the chat box. So if you have any questions or I said anything wrong during the class, or just simply you have something to share, just open your mic and speak up and just stop me. It's okay. I don't take it offensive. And I love some interactions with you guys too, because even I think in stand-up comedies, the audience contributes sometimes, right? So feel free to just like jump out and say something if you feel like it. Okay. So the textbook for this class is Fundamentals of Electric Circuits, the 7th edition. It's a really good book. In this class, we will cover some fundamentals in most chapters. There will also be some more advanced knowledge and its applications in this book that we just don't have time to cover it. So I suggest you guys to have a copy of it, and you can just rent it online or buy an electronic version, which is way cheaper than if you get a real book. And you can keep it forever for pretty low price, I think, compared to like what's cost by an actual book. And it's available in the UC bookstore online. And also, oh, did I? Okay. So also there's like you can buy it from Amazon or something like that. And so a lot of options you can choose from. But I really suggest you guys to get it. So here is a calendar version of how the class plan will be look like. I think I posted this version on Canvas too. If not, I also posted this slides on Canvas yesterday, I think. So if you more a visual person like me, so you may prefer this way instead of a syllabus. So from this class plan, normally you can see normally I will give you guys the homework assignment on Friday. So you will have a week to finish that homework and you will be due the next Friday. And we will have 6 labs spread out into this semester. They are pretty straightforward and easy. There's and I will talk to Dr. Mentai, who is teaching the same class, but in the afternoon session, that we may do a lab session combining these 2 classes together, but we're not quite sure with the COVID situation right now. So I will let you guys know later during that, and maybe a little bit earlier in that week, then we'll let you guys know how we're gonna do the lab stuff. But the lab will happen in the class session, so it won't take other your time. And the labs, like I said, the labs are really easy and straightforward. There's no lab report per se required. Just some really easy, you will have like 1 working sheet I will post on Canvas before the lab, then you need to read about it, like it's more like an instruction about the lab. And there's some really simple pre-lab calculations you have to do before the lab. And then you just simply need to go to the lab and validate your calculation result during the lab. And you just hand the worksheet to me after you finish it. So like it's pretty easy. Then there's not really that much work required you spend time on besides the class. Also, you can see there will be a test every month starting from February. So there will be 3 tests in total, and there will be 1 final exam in the final week. Any question on this part? Ooh, I see there's some charts. Oh, sorry. Oh, okay. Oh, you guys just talk to each other? Okay. Okay, that's fine. Okay. Let's see. So this is the grading. I guess you mostly care about is this part. So you can see we have like 20 points for each homework and 50 points for each lab, 100 points for each small test, and 200 points for the final. And I put 50 bonus points here because I may have some pop quizzes, or if you give me like a really good teaching advice or suggestions. Like I said earlier, this is my first time teaching. So I don't think I can be, or I will be a perfect teacher here, but I can see that I will try my best to be better. And if any of you guys can like have any suggestion, help me on how to be a better teacher, and or like the way, like how I should convey this knowledge to you, like what vibes you suggest this classroom is, feel free, just talk to me anytime in any like way, like you can just stop by, talk to me, or you can just send me an email. And also your effort, your suggestion will be highly appreciated by me. And also you can tell I try to not put a heavy weight on any part of this, any one assignment or test, because I want you guys to consistently pay attention to it and put effort into this class. It's not a really difficult class, and it's very much straightforward. As long as you pay attention and understand the concepts and rules and the method we cover in this book and practice with examples, you'll master this class, no doubt. And this class is very important foundations, even it's not very difficult for later, more advanced class, like electronics, integrated circuits, or like digital design, which are more advanced and easier to like honestly fail. So you don't want, trust me, you don't want to fail those class because you didn't do well in this class. So also like I will have online options for this class, even like throughout the semester, even after UC, because right now UC said like the first two weeks we'll be doing online, but probably will move back to in-person after the first 2 weeks. But you will still have the online options for this class. You can still join in through the Zoom. I'll have the links posted later for the later class on Canvas. So if you prefer taking it online, you can. And however, you have to be here in person for the lab session and also for the test and exam. So that's just how it is. And I won't take attendance for this class because I trust you guys as adults that you can make decisions as whether you want to learn or how you want to learn. And that decision also will reflect on your grades, of course, but I won't take attendance for this class. And every class will be recorded and the recording will post on Canvas because like, I know, like I understand you have life outside of school. So like you may sometimes will miss class. So there will be videos if you want to catch up later. But I won't suggest you if you don't have to miss the class. I won't suggest you because you may end up, okay, you think, oh, because I don't take attendance. You're like, okay, I don't have to get up this early for this class. I'll just watch the video. And then maybe like that's a really easy slope and you end up with have 10 videos to watch before some exam. So you don't want to get into that. So suggest you don't try to not miss any like live class or in-person class. Anyway, so also like I said, I understand you guys have life beyond outside of school. So if you have any personal situation of life happens, you have any life situation which may affect your study, and you think I can help in some way, and feel free to just talk to me, reach out. Like we will see what we can do together to figure out, because I'm here to help you to succeed, and I want every of you can be successful. I'm not here to make your life difficult. I'm simply here to help you understand this knowledge and help you to be a successful engineer, or somehow like, or if you don't want to be an engineer in the future, but like learn something from here. So like just feel free to reach out to me and we will see what we can do. Any questions on this part? Okay. So that's basically what I want to cover for the introduction part. And we'll like I said, this is the first class, so we'll have a really like pretty shorter. We'll have a shorter session than the normal session, but I'm still gonna cover a little bit basic concept from the chapter 1. So if you guys don't have any questions, we'll just carry on. Oh, also, if I speak too fast or you think my speed for this like class is kind of like you want me to slow down a little bit, just like let me know. Okay, seems like we're fine. Okay, let's start our first class. So this class called network analyze. So the network here is referred to electric circuits. A lot of like complicated electrical systems such as electric machines or power machines, communication system, or integrated circuits. The fundamentals of all of them is just like really simple electric circuits. And electric circuit by definition is an interconnection of electrical elements. So here I have one picture shows a very simple circuit consisting of 3 elements, a battery to provide the energy to the whole system, and the wire to transfer the energy, and the lamp to consume the energy or convert the electric energy to luminous energy. And here's another picture showing a more complicated circuit representing a schematic diagram for a radio receiver. Even it looks like really complicated, a lot of elements right now, but you will be able to analyze it after this semester using the method we will cover later in this class. So before we dive into the electric work, there's a quick review on the 6 basic units and with the 6 basic physics quantity. The length, mass, time, electric current, temperature, luminance, intensity, and charge, and with also like the basic unit for them. So all other physics units we need to learn in the world right now can be built based on those units. And of course, we'll focus on the current and charge here for this class. So what is charge? By the textbook definition, charge is an electrical property of the atomic particles of which matter consists. It's very mouthful and like, yeah. So charge is actually the energy carried on those little tiny particles like atoms or electron. It's like nowadays, like it's winter, it's cold outside, and when you take off your sweater, sometimes you hear or even see those small sparkles. Those are like charge being released. The unit of charge is Coulomb, and Coulomb is a big unit. One electron, which we normally write as the little q, has negative 1.6 times 10 to the negative 19 Coulomb. And one really important feature of charge is that it's mobile. So as the figure shows here, if we're connecting a conducting wire to a battery to form a circuit, and the charges are compelled to move in certain way. Like positive charges move in one direction, and as shown in the figure, the negative charges will move in the opposite direction. And this movement of charges create an electric current. So electric current is defined as the time rate of change of charge, which is charge changes in a time minor. Having unit in amp in honor of this great French scientist, who was one of the founders of the classical electromagnetic, which he referred to as electrodynamics at that time. And you guys will take the electromagnetic class in the 3rd or 4th year, I think. It's a very interesting class. Difficult, but interesting. He is also the inventor of many applications, such as electrical telegraph. Conventionally, we define the direction of the positive charge movement is a positive current direction. However, just keep this in mind. For example, as the figure shows here, a positive current can be the result of a positive charge moving. For example, this figure shows here, like this current can be the result of a positive charge moving in the clockwise direction, but also can be the negative charge move counterclock directions. So as we stated, the current reflects charges varying with time. So it doesn't have to stay constant. Periodically, the charge can change whatever it wants through time. But generally, we have 2 common types of currents. One is DC, which is direct current, and AC, alternating current. DC only flows in one direction, as shown in the figure A here, and AC AC charges change its direction periodically, as shown in the figure B here. So one quick question: what current is this figure shows here? Anyone? Oh, AC. Interesting. Anybody have different ideas? Actually, it's DC. So even though it looks like the curve is kind of jumping. Oh, sorry, I missed this. This vertical axis is current, but even the magnitude of this current changes. Like if you simply just looking at this, it looks really like this one, right? It looks like figure B. But however, if you pay attention, like this magnitude stay on the positive side. So which means even the magnitude of this current changes over time, but the direction didn't. So it's still based on the definition. Like if this is, if it's AC, oh yes, yeah, we have one. Yeah, if it's AC, then the direction of this current has to change with time, but this one didn't. The electric charge and current only flows in positive direction, even with a magnitude change. So it's still DC. Okay, there's some common sense. Let's see. If we have a water pipe and we want to have a water flow out of it, and we know we got to have put some pressure or force to achieve that. And same concept for current flow. If we want to keep a current flow in a circuit, we have to have some sort of electric force to push those charges in the circuit to move, right? So like in these figures, the battery here is actually providing this force in this system. And we call the force the external electromotive force, or we call it voltage. So voltage is defined as this energy or work needed to move a unit of charge from point A to point B. So we call that voltage AB. And voltage AB can also be addressed as a potential difference between point A and point B. So it reflects as potential, the voltage AB, which is the potential difference between potential A and potential B, is the potential A minus potential B. And the unit of voltage is volt, which is also in honor of another great Italian scientist. And there's also positive voltage and negative voltage. We see current flow from higher potential to lower potential. So if current flow from A to B, and then the potential A is higher than potential B. But you have to be really careful here, because this higher we mean here is only means magnitude higher. So in this definition, voltage AB, if the current is flow into A from B, the voltage AB is positive and voltage BA is negative. Any question on this part? Okay. So another concept here. When we go to buy like lights in Target, and we always see their signs on the box saying, oh, for example, 25 watts or 60 watts. And the 25 watts and 60 watts number is electric power. And power is the time rate of expanding or absorbing energy measured in watts. So mathematically, power is equal to dW, which is the energy over dt, like changes over time. And we know voltage is a concept defined to energy, and a current is a function of time. So let's do some little trick here. So let's change the dW over dt to dW over dq, then multiply dq over dt, which then converts this whole power to a product of voltage times current. So power is equal to voltage times current too. And let's look at this figure here. Anyone can anyone tell me why the power in figure A is positive V times I, and in figure B, the power is negative V times I? Anyone? Yes, yes, correct. So like if we define you all have if we look at the figure and if we define the direction 1 to 2 is positive in A, then current I is from A to 2, so it's positive current, and voltage V is positive V across V1, 2, so the power is positive. And in figure B, the current flow actually flow from 2 to 1, which is against the positive direction we assigned. So it's make it negative current. So the power is negative VI. So a quick practice, actually same, just I assign number on it. So what's the power for figure A and figure B in this figure?
Would A be positive 12 and B be negative 12?
Anyone have different idea? Be careful, watch closely.
Oh, they flip the positive and the negative. I see. So would they both be 12 then?
Yes, correct.
Okay.
So both of them are 12. So watch carefully, be careful. You want to pay attention. When you assign the positive direction for the whole system, and pay attention to both voltage and current. Yes, so how about this one? What's the power for this two? Yes, correct. So both of them will be negative 12. Okay, this is the last slide for this class. Like I said, it's gonna be end really quickly. Well, so the unit we normally see every month on our utility bill is like kilowatts hour, which is not a power unit, it's an energy unit. You can tell it's by kilowatts times hour, which is a ton. So the energy is which like this concept which stand for energy consumed over a period of time. You can tell by the unit. In international unit system, energy we usually use joule. So here is a easy convention. Like 1 kilowatts hour is like 1,000 watts times. Here 6 stand for 60 minutes per hour and 60 seconds per minute, and end up with this big number. And that's usually what we see in our utility bill. So yeah, that's basically what I want to cover, some like really easy basic concept. I want to cover the first session. The next session, we're gonna learn more about like the elements in the circuits and do more practice with it. But yeah, this is what I have for today's class. Anyone have questions regarding anything like this class, or any questions for me?
Yeah, I just wanted to clarify, we're
Okay.
For the first 2 weeks, right? We don't have lab, or do we have lab this week?
No, you don't. So for the first, if you see, for the first 2 weeks, you don't have any labs, and also next Monday is a holiday, you don't have class, and you will have one homework due. I will post the homework this Friday. You will have a homework due next Friday. And
Okay.
all the class is like online, though no in-person session. And if you want come in person, like we'll start in-person session according to UC right now. The policy is we'll start the 3rd week. But if you prefer still doing online, so I will still have this like Zoom set up, so you can still like hook online, so you can still like join in through online.
Okay, perfect. Thank you.
Oh, and also, so right now I don't have the exact date for exact date, like which like even during the lab week, like which class will do the lab. I will talk to Dr. Mentai about this, and I will let you guys know maybe a couple days before when exactly the day will be the labs, so you can be prepared and come in person, because we do, so at least for now, like based on the policy you see have, we do require in person for the labs. Any more questions? And if no, like you guys feel free to leave. Like today's class is just gonna end here. Yeah, see you guys tomorrow.